Hello and welcome. My name is Byram Boyku, and I want to thank you all for joining today's webinar. Our webinar topic today is Migrating Your Database to Snowflake with Open Source. We're going to take a look at how we can leverage open source software, namely RosettaDB, for database migrations. In this webinar, we'll discuss some challenges with database migration and explore how we can leverage RosettaDB, Jupyter Notebooks, and Spark to migrate both database objects and the associated data. We'll discuss some of the challenges one typically faces with database migrations. We'll explore RosettaDB as an open source alternative to help solve some of these challenges, and we'll walk through an end-to-end demo of migrating both Postgres and MySQL databases to Snowflake. Today's presenter is Nuhi Basimi, and he will give us a hands-on perspective of how open source software can help with migrating heterogeneous databases to Snowflake using no-code and low-code approaches. Nuhi is a co-founder of Adaptive Scale and the chief data scientist. He holds a PhD in data science and is an entrepreneur experienced with managing teams and technology business operations. In addition to his extensive academic work in data science and big data, he's worked with some of the largest U.S. companies supporting their big data operations, numbering in the thousands of nodes. Without further ado, I'd like to turn it over to Nuhi now. All right, Nuhi, you may take the controls. It's all yours.
Thank you, Byram. Thank you for introducing the topic for the webinar today. So I'll continue now with my today's presentation on the topic migrating your databases to Snowflake using open source. So one of the main challenges, one of the reasons why we have chosen this topic is that today there is a big problem in terms of migrating databases, creating warehouses to cloud, and database migration is a pain. Moving your data objects can be a very challenging process, difficult at the same time, and time-consuming. The reason for that is because today there are a couple of challenges that engineers are facing while trying to solve this type of problem. One is there needs to happen a lot of conversion from source database to target database. In our today's webinar topic, the target database is going to be Snowflake, and we'll see how we can move data from Postgres or MySQL to Snowflake and see that if we do not have some sort of automatic tool to do that, it requires lots of DDL and DML operations to do manually. On the other hand, there are open source tools that help in certain ways, but none of these tools does provide an end-to-end solution. And which leads you to building your own conversion scripts and lots of management in terms of scripts and such. On the other hand, there are a vast amount of ETL tools, either open source or commercial, which they have limitation in terms of doing this database migration, because one of their main challenges is that they do not focus mainly on the data types from the source and mapping them to the right data types to the target. So therefore, ETL tools usually use some middle layer like a JSON or CSV, where they export the data, and then just by importing the data, they just create the schemas. And this way, they do not keep the original values of data types, and having correct data objects on the other side of the target database makes it very challenging, and it requires then a lot of manual work to finish and do all that process. So one of the main goals today will be, let's ease this process. Let's see how we can use open source in order to make sure that this process will go smoother. The solution that we present today is called RosettaDB. You can get it on GitHub. It's free. It's open source. What is RosettaDB? RosettaDB is a declarative database modeler. It will allow you to model your database object by using a declarative language. We will use YAML, and we'll present the database objects in YAML format. RosettaDB acts as a DDL transpiler that will allow you to migrate from one database to another and translate the schema and all these data objects from one database to another. It's a DBT model generator. It also acts as a database testing toolkit, which is very important today to ensure the data quality and make sure you detect anomalies on the data itself, either before the migration process or after the migration process has happened. The usage of RosettaDB is pretty straightforward. It's free. You simply get it from GitHub, you configure it, and by using the CLI commands, you simply get to start migrating your databases from one source to another. The main focus for today's webinar will be in two parts. We will see how RosettaDB will help us and how it will act as a DDL transpiler to convert the schema from one database to another. And there is a list of supported databases, and you can see this list also in the website as well. And the most popular databases that engineers are using today are already supported, so that's something that you can use. And the second part about today's webinar will be, let's see, data quality and how we can utilize the open source RosettaDB to detect data anomalies, and how we can write automated tests and to write assertion-like tests on top of your data. We will see that this can be also done on the source table before doing the migration itself. And on the other hand, also on the target table when the data movement has happened, and so on. That's enough related to the intro. So now let's move on and see the real demo on what we are going to show with RosettaDB. The use case for today will be, we have a database in Postgres, and we have a database also in MySQL, and we'll migrate the databases that we have in Postgres and MySQL in Snowflake, and see how RosettaDB will help us as a DDL transpiler to convert the schemas and create the schemas for us. And we will use Jupyter Notebook with PySpark to do the data migration, and we'll see how RosettaDB is helping us also in that field. And the final part of today's demo is going to be checking the data quality and ensuring how easy it is to do that with RosettaDB. Before getting started with the demo, I would like just to show all of you that if you want to have access to RosettaDB and start using that on your own, all you have to do is just go in GitHub and get it. Under the README section of the RosettaDB, you will see all the details required in terms of getting started, prerequisites, configurations, and so on. And all the details related to various functionalities that RosettaDB is offering, and also the latest versions and the releases that we have had recently in RosettaDB. On the other hand, you can also reference the RosettaDB website. Here you have an extended version of the documentation. If you are interested in more details about various functionalities of RosettaDB, the supported databases, on how different functionalities operate, and so on. So feel free to visit also the documentation of RosettaDB, reference it for various use cases that you might have. In the GitHub page, you can already see that there is a getting started section. I have already gone through this process. I have set up a RosettaDB project in my environment where everything is already ready. So RosettaDB is a CLI tool that will allow us simply to start to extract database objects from the various data sources that we have configured. So an initial RosettaDB project looks as follows. We have a directory. I have created a project from RosettaDB, which called database migration. And in this directory, we have one configuration file. As part of this configuration file, we specify all different connections that we are planning to use as part of this project. Since for today's use case and demo, I'm going to connect to a MySQL database, to a Postgres database, to a Snowflake database. I have written all my connections here, the schemas where I want to connect, the credentials that I need, and so on. So the main.conf is mainly responsible to specify the configuration of various data sources that we are planning to use. If, for instance, we want to also use an Oracle, or we want to have additional Postgres database, we can simply just add the connections here, specify the JDBC connection strings, all the needed options, parameters, configurations, and we are all set up. You will notice here that I also have a driver called a folder called drivers, and since RosettaDB behind uses JDBC drivers to connect to these data sources, collect the metadata and all their schemas, and do the translation, we need the respective JDBC drivers in order to establish that connection. I am using the MySQL, Postgres, and Snowflake JDBC connectors. So as soon as I have the driver set up, have the connection set up, I'm ready to get started with Rosetta and do some database migrations. So in order to get started, simply first, I'll just make sure that Rosetta is properly configured. I can access the Rosetta CLI and everything is okay. So first thing that I want to show is how Rosetta is able to extract the metadata from one of the sources that we are working on. Let's assume we want to see what tables we have in Postgres. Let's extract the schema, the metadata, and see how Rosetta presents that. So there is a Rosetta extract command that gives us the ability to extract the whole schema from the Postgres, including all the details and metadata about tables, schemas, foreign keys, indexes, and everything that we have as part of the database in Postgres, and write that in YAML format and represent that as a DBML. So with Rosetta extract -s standing for source and Postgres, we are expecting for Rosetta to connect to Postgres and extract the schema of the actual tables that we have there. So this command is it uses JDBC to connect to Postgres, extract all the needed details, and you will notice one thing. After a successful run of this command, there was a new directory created, Postgres. And the directory name and this Postgres here comes directly from the configuration that we have here, because I already have a configuration with name Postgres. So that is why I'm referencing Postgres with this keyword. If you have another Postgres connection with some other name like PG or PG Cloud or something like that, you can reference with the connection name and make sure that you extract the data objects that you are interested in. So moving forward, the Postgres directory that got created here inside has the DBML of our database. It has a YAML file called model.yaml that actually represents the complete schema and structure of all the tables that we have inside the Postgres database under the connection that we configured in main.conf. And probably you can see that there is a table actor, which is under the schema public. There are some indexes configured here. There are columns. All the columns have data types. There are some additional configurations and attributes in terms of all these database objects. So the thing is that RosettaDB easily can extract your schema, and then now you have a better understanding on how everything is organized under Postgres. But let's assume, okay, how we can now migrate this schema to Snowflake? Is there a way for Rosetta to convert this schema and make it ready for Snowflake, so we can simply create the same database objects that we have in Postgres and create them in Snowflake and make sure that the schema conversion is in place, that all the constraints are in place, and all the data types do map, take into consideration that Postgres and Snowflake are not the same. So to do a conversion and create a similar YAML representation of a database schema in Snowflake, we simply need to run Rosetta extract. But this time, instead of specifying only the Postgres as a source, we can specify a target Snowflake. We already have a configuration with name connection Snowflake. So we simply go Rosetta extract. The source is Postgres, the target is Snowflake. And now our expectation is for RosettaDB to connect to Postgres, extract the schema, generate the DBML, convert the Postgres DBML to a Snowflake DBML, and generate a new directory where we also have the DBML representation, the YAML representation of the Snowflake. So as we can see here, now we have a new model.yaml, another directory called Snowflake, and this directory here is, this file here represents the conversion of the database objects from Postgres to Snowflake. But we haven't yet migrated, so we didn't do the migration yet. This was just the conversion. And here we can review this process. We can see if we are happy with the model.yaml of the Snowflake, if you want to add something, remove something and stuff. But I'm not interested in making changes right now. I just want to have a one-on-one mapping. Everything that is in Postgres, let's move to Snowflake. So if we want to apply these changes and create these database objects in Snowflake, Rosetta can do that for us as well. But before doing that, I will go ahead and generate the DDL just to see for reference how that looks like. So before applying the changes to Snowflake, I'm going to ask RosettaDB, generate me the DDL and how the DDL will look like if you are going to apply these changes to Snowflake. So there is a command in Rosetta called compile, and we can use Rosetta compile. The source is Postgres, and the target is Snowflake. And as a result of this command, we are going to get a file after the conversion, which represents the ddl.sql. And inside here, we have the Snowflake DDL script that RosettaDB can use in order to create all these database objects and all the constraints with all the data types, which are based for Snowflake for us directly in Snowflake. So the compile command had one job, just to generate the DDL, and for us to review it. If everything is okay, we can continue and ask Rosetta to apply the changes. Or if we want to just copy the DDL and use a different approach and run the DDL manually on our own, modify it in places where we want, and just continue creating those database objects using some sort of DB client. We are okay now with this DDL, with the conversion, and we can simply go ahead and say to Rosetta, Rosetta, apply source Snowflake. This is one of the most important functionalities of Rosetta. After we did the conversion, all the data types and stuff, we did the verification. Now we can ask Rosetta to go connect to Snowflake and create all these database objects for us. So as soon as we click Rosetta apply -s Snowflake, this is going to take a couple of seconds, depending on the number of database objects that you have in background to create. While this is running, I have already also opened my Snowflake UI here. So let me go back to the command. The command did finish, successfully written DDL, successfully applied the changes in Snowflake. So before going to Snowflake and seeing the tables there and everything there, I want to show some things, some directories that Rosetta has created for us before applying the changes to Snowflake. One thing that we have here, and it's new, under Snowflake, we have snapshots. In the snapshots, we have a model.yaml, a TBML, a YAML representation of the Snowflake schema, Snowflake state, before applying the changes. And as expected, before applying the changes, we have nothing in Snowflake. And we also have another directory, which is apply, with a timestamp. And here we have the script that RosettaDB has used in background in order to create all those changes for us in Snowflake after the translation happened. So everything went as expected. The command got run successfully. Now, if I go to the Snowflake UI, I refresh the page. This is the demo database that we are using. Now here I can see a schema called public, where inside here I can see the new tables that just got created as a result of the RosettaDB apply command that we hit run before a minute. So what are the end results here? As a result of this command, we can see now that all database objects got created in Snowflake. All the conversion from Postgres to Snowflake happened. RosettaDB helped us there, and all the tables, relationships are already now created in Snowflake. You will notice that these tables exist. They have the schemas. They are created under the public schema because that was the schema that we used in Postgres, and we did not modify anything in model.yaml because we wanted to have a real one-to-one mapping on what we have in Postgres. So this way now we can go ahead and verify that all the tables are okay. If I go under data preview, we don't have data. because the goal of the Rosetta was to migrate the data objects and make sure that you translate the schema that you have in Postgres to Snowflake and ask RosettaDB to create all those tables for you. Now, the next step will be, let's move the data. So in order to move the data, we are going to use PySpark. I have already set up a Jupyter Notebook with Spark installed, where we can simply just connect to the Postgres database, fetch all the data for all these tables, and write them directly in Snowflake. If we are interested how to write that PySpark script, RosettaDB can help us to generate the code for us. So we simply go ahead, copy and paste that code, and we execute that PySpark either in that Spark code, let's say either in Python or Scala, in any cluster that we are interested. So sometimes you may have use cases where the size of data is huge, is large, and you might need more resources to move all the data and stuff. You want to do some modification on top of that. So what I'm going to do now, I'll ask Rosetta just to generate the script for me, and then copy and paste that script, run the PySpark command, and see how the data will move to my target database, which in case here is Snowflake. So to do the script generation, the code generation, Rosetta CLI has a command called generate. We specify the source, which is Postgres, and we specify the target, which is Snowflake in our case. Why we need the source and target? Because when the code gets generated, Rosetta knows how to generate also the connection strings for us, knows which tables were involved during this database migration process, and knows exactly how to connect to the source, extract the data, how to connect to the target, and write all the data there. So Rosetta generate by default is going to generate a Python PySpark code, but if you are interested, it also generates a Scala code. So besides on your needs and your preferences, you can use either Python or Scala to move your data. So if we go now under the Postgres directory, since the Postgres is our source, you will see that here now we have a Spark code, a complete Spark code, which knows how to connect to the source database because we already provided this information, knows how to connect to the target database, knows the list of tables, and it simply goes, reads all the tables from the source, which is Postgres in our case, and writes the data from the source to target, which is Snowflake in our case. So in order to play with this, all we have to do is just copy the code, go to the cluster where we want to execute it, and I already have here a Jupyter Notebook where I can run the code that got generated there. So simply all I have to do is just make sure that, okay, I did run this but previously, but doesn't matter. Now the tables got created from scratch. So I simply paste the code here and hit run to make sure that things will go as expected. We have some logs showing that now we are migrating actor table. We are showing top 3 rows from actor table. We are then migrating the address table, showing top 3 rows from address table. Then we are migrating category. And this process now is something that runs on Spark using PySpark, and all the data is moving from Postgres to Snowflake. In order to make sure that, yeah, the data is actually moving while this is running in background, I can go to the my Snowflake database. I'll click refresh here. I'll click actor. Let me see now the data preview until Snowflake refreshes here. Let me refresh the wall page. Okay, under the data started flowing. So we can see actors now. We can see that under the actor table, we already have 200 rows. If I go under address, again, here we have data. So the process of migrating my Postgres to Snowflake was pretty straightforward. All I had to do was use RosettaDB to migrate my schema, to convert my Postgres schema to a Snowflake schema, apply modifications if I need, apply those changes, ask Rosetta to do those changes for me, create the database objects for me, and then use any tool you like just simply to load the data. But now, as soon as I'm loading the data, the schemas do match, and I have exactly a one-on-one mapping of what I had in Postgres. Now everything is here in Snowflake. Since we did this with Snowflake, it was pretty straightforward. let's continue with the next case. Let's assume now I have more things. I have another schema that I want to move. I have more database objects which are not located in Postgres, but they are located in MySQL. And I want to move them, same here, in another schema in my Snowflake cloud platform. To do that, I'll go now again to my Rosetta project. This Rosetta project is already configured to connect to my MySQL instance where I have database there, I have tables, I have data. So I simply can do Rosetta extract whatever I have in my connection, which is the source MySQL, and I want immediately to convert that to the target, which is Snowflake in our case. So it will go to MySQL, connect there, extract all the database objects, generate the DBML for me. At the same time, do the translation and generate the Snowflake model with the schema and data types mapped to Snowflake. Now, we have a new Snowflake here, a new schema. This is another schema. It's not the public schema because these tables now are coming from another database. If everything is okay, I'll just continue now and do Rosetta compile from my source MySQL to the target Snowflake and see the DBL that it's going to generate. The DDL is ready. I can review it. I can see how things are going. The table, the database objects are similar, but not exactly the same compared to the previous case that we had. And next, if I'm happy with what I have currently in my model.yaml, I can simply say, okay, whatever you have in that DBML representation in that YAML file, take all those database objects and create for me in Snowflake. So simply say Rosetta apply resources Snowflake. It connects to Snowflake, it runs that DDL for us, and the expected result is that a new schema with more tables should be now available in Snowflake. As soon as this process finishes, we'll go to the Snowflake UI and see the result. Okay, it was successful, it finished. Let me go to the Snowflake UI, hit here the refresh button, and we have one additional schema under the demo database. I click here, I have more tables. The table names are similar, but now these tables do not have data. They have a slightly different schema because now it's MySQL, they have different data types, and the translation process does adapt moving from MySQL to Snowflake. So the next thing is, let's move also the data. Now the data is in MySQL, let's use PySpark to do the same process as we did with Postgres. To do that, I will generate quickly the Rosetta PySpark script in order to move my data, generate from source MySQL, in this case, to the target Snowflake. So right here we have now under MySQL, we should see a Spark code. Yeah, this is very similar to what we had before, but now the thing that changes, it connects to another source database and the list of tables, depending on the list of tables that we already have on the MySQL database. You simply, all you have to do is just copy this and go to your cluster and run the command. I have here the connection to MySQL, to Snowflake, and let's go ahead and create this. So I'll hit run. Starts with the actor table. It moves data there. It starts with the actor genre, probably no data there, nothing showed the data frame, that's okay. Category, and so on. So while this is running in background, I'll go in the Snowflake UI and make sure that all the data is getting populated. Let me go to the actor data preview. Okay, Snowflake likes to click refresh here, or maybe they want a hard refresh. Go actor data preview, and my data is here. I go to address data preview. Yeah, my data is here. So it took me just 2 minutes to move like more than 15 tables from my MySQL database together with my data to Snowflake just by using RosettaDB as a DDL transpiler and using Rosetta to generate for me the PySpark code, so then simply I can just grab whatever I have in MySQL to Snowflake. Whatever I had in Postgres, now I have in Snowflake. Why Snowflake? Because Snowflake is one of the most popular database cloud solutions today, used for various use cases, building your data warehouse, performing analytics, and so on. And one of the biggest challenges that companies are facing today is migrating their databases to Snowflake and doing lots of manual work. So RosettaDB is free open source solution that will allow you to do that just in a few minutes and take into consideration all the details about various data types, conversion issues, and challenges that you might have during the road. This was the first part, what we wanted to show about the webinar. The second part will be now, let's see how RosettaDB can help us to ensure data quality. Data quality is a very important topic. Yeah, we migrated. And one of the main questions that usually arises is, who is going to guarantee that the data that was in Postgres was the right data for us, or there were no anomalies, or we want to do some pre-checks before migrating our data to Snowflake? Or the same question can be also in terms of, what if we want to do checks also in terms of, we have migrated the data, but let's make sure that all the data meets the criteria, the verification, the rules that our data team or engineering team has applied. So RosettaDB also has the capability to act as a data quality or a test framework in order to detect anomalies, test your data. It connects to the database and it can check for various rules that you can specify. How that is done? Let's go to our project, which is already here. And what I'm going to do, let's go with the first use case. For instance, we did an extract of Postgres, but let's assume that we want to check something more specific. We want to put rules on specific columns about various things that we are interested in. So some rules that I might do. So here I can pick any column I like, any table, anything I need to verify, and writing test cases is pretty straightforward. All we have to do is just define the tests. Tests work in assertion-like process. So I need just to put an assertion, specify the operation. In our case, I'm going to check for columns which are equal to the value that I'm interested, for instance, 100. I know that there is an actor with an ID of 100, and I expect that I must have only one row with that rule. So this is a rule that I put in place to confirm that there is only exactly one row matching the criteria that I just wrote here. Similarly, I can write some other criteria, for instance, for the first name. Let me write the criteria for the first name, checking for the value. I don't know, I think there is a John, something like this. Yeah, there should be exactly one user with name John. And this is the criteria that I'm putting for the first name. And I can do similar checks. I can write similar rules for various things in order to verify that my database, even before the conversion process or migration process happens, or after the migration process has happened, you do various checks and you do various tests in order to confirm that, yeah, it meets the rules, continue with the next process. So how we can run these tests now? Rosetta has a command called test, and you simply need to specify the source where you want, which test you want to apply. Since now I chose randomly Postgres, let's run the test that I have written in Postgres and see what will be the output of the anomaly detection of data quality about this process. Okay. Oh, I have an operation. Let me write this correctly. Tests, assertion. I have a typo right here. Operator. Sorry for this. So this is an operator, then value. Yeah, makes sense. As the Postgres, it found two tests in my Postgres database, and it says, yeah, your test about checking that there exists one value, one row where actor ID is 100, that's correct. It's expected one, actual one, that passed. But you are we are expecting to have one row where the first name is John, but we have 0 such rows. And this is probably because if we go under the actor table, I think probably I might need to do all uppercase. Yeah, we have something like this, John, and not. That was expected. If there are more Johns, again, the test will fail. But yeah, it looks like there is a single row with first name John. That is our expectation. The test passed, both tests passed, and we can have as many tests as we want. So RosettaDB is also capable of connecting to your database, and based on the rules that you have defined as part of the test that you have written for various columns, it runs them and checks based on the actual values that it receives and the values that you are interested in. So as a result of this, this is related to how RosettaDB can help you very easily achieve all your goals in terms of migrating your databases. Other targets, in our case, is Snowflake, and you can migrate from one database to another very easily. Just go ahead, check all the supported databases that RosettaDB has today, and you can go from one database object to another without any issue, because all the translation rules are there, and RosettaDB will do all the job for you in background to do that migration. So that was related to the demo. Some details in terms of, since RosettaDB is open source and you can go to GitHub and get it. How to contribute? You can always go to RosettaDB website, try it, play with it, and if you are interested, feel free to create a PR or just Slack. There is a Slack channel. You can just contact us, add recommendations, ask for any database or anything that you are interested related to the project, how to make it better. Definitely, there are more database vendors out there. We can add more translators, and we can do more test types in terms of data quality. So that part can also be extended in order to meet various criteria and requirements that companies and data engineers have today as part of their daily life. So thank you for your attention. I wanted to make this easy to understand, easy to visualize, and see how you can move your database objects and data in minutes just by using open source. I'm looking forward to questions, answers, recommendations, comments. Byram, if you have been monitoring the chat or something, so.
Yes, I have a few questions here. Let me send them over to you in the chat. I'll pull up in your chats window in a second.
Okay. Okay. So, do you provide commercial support? The answer is yes, we do provide commercial support. And I'm glad we have this question, because if you are not familiar with the CLI tools and this looks complex and you want like a more better solution with better user experience and stuff, everything that I showed today with the open source tool and with the, as part of this webinar to migrate your databases to Snowflake, we also have a nice UI that you can use, and that is called RosettaDB Cloud. So all of you who are interested to use the same things, the migration process, similarly to what we did with the CLI part, you can also set up an account under the cloud.rosettadb.io and use all these functionalities and have nice and clean UI with all the details in order to configure data sources. And here, in my case, I have one data source, which is Snowflake. You can go ahead and explore your data and use this great UI element to explore your data and see schemas and tables inside Snowflake. And at the same time, you have the ability, instead of going and writing all your commands manually and configuring your environment manually, getting that CLI up to work, you can go here in the UI, configure your data sources, and then start creating collections and deploy them and start to move things from one source to target. So we might organize a different webinar where we'll discuss how that can be done. And in addition to what I just showed now with the cloud.rosettadb.io, yeah, we as a team do provide commercial support for companies and enterprises who need support in terms of how to migrate from various database vendors if they have specific use cases, and how we can utilize RosettaDB or RosettaDB Cloud in order to make this process smoother and easier and more manageable for everyone. Okay, there is a question. I see a dbt folder created when you run the compile commands. What's in there? Perfect. The goal today was mainly to migrate databases, objects, and to see the data quality. RosettaDB also offers you the ability to generate the dbt models for you for the sources that you have already configured here. And I'm going just quickly to show how that looks like and how RosettaDB is able to generate that, and which will give you then additional benefits if your team is already using dbt, they are utilizing dbt after the data is in Snowflake for various ELT processes that you might have in place. So let me go to my Visual Studio Code real quick. Here I have for my Snowflake, I have a dbt directory. Inside my dbt directory, I have my dbt model.yaml, and under model, I have my dbt presentation of every table that we have as part of the source or as part of the use case that we were demonstrating. So this is these are all automatically generated dbt models by RosettaDB, and that's something that you can simply just have your source, and if you are dealing with dbt, this is another very time-consuming job that data engineers do spend lots of time in. So you simply can use RosettaDB just to generate dbt models. On the other hand, if I go here in the cloud part, I can also extract the dbt models very easily directly from this section. So for every table that I have, similarly what I see in the CLI part, in the here I have a nice UI where I can select my table and just extract the dbt model for it and continue with next things. Going with the next question is, I have Teradata database. How can I use Rosetta for migrating from my system? Okay, if we go in the documentation of RosettaDB, Teradata is not listed here, but that's not a big problem, because RosettaDB is a platform that in background utilizes a translation matrix. If we want to add a Teradata database, that is something that we can add very easily in part of the Rosetta, because all simply we have to do, our engineering team or also people who want to contribute can do this. They get the all supported types of Teradata, and they go ahead and see what are the details that we need in terms of whenever we want to have a support of migrating Teradata to Snowflake. And initially, the first thing that we can have and we can easily integrate is, for instance, let's assume I have a Teradata, I want to move to Snowflake. We only need to predefine all the details and rules about various data types that and update that translation matrix with these conversions. The next thing will be you provide the JDBC driver of Teradata, and then RosettaDB will do the magic in background. RosettaDB set up my entire Snowflake environment with CI/CD. There are things like, since RosettaDB is a CLI tool, the open source, its free version, we have some use cases where we have integrated RosettaDB as part of the various CI/CD pipelines to perform things like migrating data, checking differences of the data, migrating database objects, and so on. But I think for more details related to that, you might need Terraform or Airflow for orchestration to your project in order to make that process simpler and easier. On the other hand, there are solutions where RosettaDB can easily integrate it in CI/CD-like solutions. Since it's a command line tool, you simply get all the dependencies you need, you provide the jar files, and you start to integrate that as part of your data pipeline for various use cases that you might have. Okay, Byron, I think these were the list of questions that I got. So thank you all for your attention. I hope you enjoyed the presentation for today on today's webinar topic, and I hope you find this helpful. Thank you.